So the 30-second problem in the Leet code is to find out the longest valid parenthesis. Okay, here will be given a string which consists of only open parenthesis and closed parenthesis. We'll have to find out the longest valid parenthesis. Okay, so previously we had solved a problem similar to this where we were asked to just check if it is valid or not, correct? So what we have done was, like, we used to push any open parenthesis, right? We'll push it to the stack. Whenever we encounter closed parenthesis, we'll check if there is anything left in the stack, right? If there is anything left in the stack, it means that there was an opening parenthesis for this one, correct? So once we encounter that, like, I mean, if we had something in the stack, it means that it's a valid one. We'll be popping that out. Okay, and similarly at the end we'll check once we are done all this calculation, right? And if there is no respective element present in the stack, it means it's an invalid. And also last thing, at the end we'll check if there is anything that is left in the stack, right? Anything left to open parenthesis which does not have a matching close parenthesis, right? We'll check that. Based on that, will it is a valid or invalid, right? Okay, this is one thing. But this time what we need to do is we'll have to find out the longest valid parenthesis. This is a valid one, correct? So this length will be 2, and here this is a valid length will be 2, and this is a valid length will be 2, but it's a consecutive one, right? We'll need to find out the longest one. The longest one would be from starting from here to here, correct? Starting from here to here. So it means that we say 4, its a value is 4, correct? Like, I mean, the length is 4. So when we are doing this calculation, it means that we are starting our calculation from here to here. We need some start pointer, right? So that I can take a diff and I can calculate the full length. Like, it is like ending minus start, and I can get a full length of it, correct? So what we'll do is we'll initialize the start is equal to -1, because yeah, right, this is a string, right? This is a string, and we can set our pointer to here. Start is equal to -1, so that maybe let's forget if we have this. Okay, let's forget this, we have this. Okay, for timing. Okay, let's say that this is our string. So what I will do is I will spread the we'll set our pointer, okay, to -1. Just assume that we don't have this. Okay, this will set our pointer to -1. So what I can just do is, once we encounter this closed one, right, so I can take a diff of it, correct? I can take a diff of it and I can get a length of it. Okay, so that is the reason we can make use of the start pointer. So just to see it clearly, right? Okay, so let's say that this is our start pointer. Okay, we'll be setting our pointer to here. Okay, we'll be setting our pointer to here. Okay, look, before actually that, so let's say that we have just this thing, right? We could actually rely on, this is our start index, this is our end index, right? When we pop it out, we know what is the closed index. We can just take a diff, correct? We can take just a diff, and we'll get a length, correct? That is also done. But the thing is, let's say that we have our configuration in this way. Okay, we have our configuration in this way. It is not encapsulated anything, correct? So this will be our starting index, and this will be our 0 1, whatever it is, right? Whenever we pop whenever we try to find out the matching element, it will be getting some index here, correct? We'll be getting index, and it's the always will get a length as 2, correct? Always will getting the length as 2. So that is the reason we'll be needing one start pointer before to it. Okay, so so that's the purpose of initializing it to the -1. Okay, like whenever we start, right, the array starts from 0, but we'll set our start pointer to the -1. Okay, that is one thing. So now coming to the actual implementation, right? Just like the previous, we'll be checking when we are checking the if it is a valid parenthesis or not, right? Similarly, we'll do that. We'll iterate from left to right. Okay, we'll iterate from left to right, and we'll push whenever we encounter a closed parenthesis. We'll push to the stack, and whenever we encounter a closed parenthesis, we'll do our validation. Okay, so first thing is, okay, when we encounter this, we'll push this to the stack, push to the stack, and when we encounter this thing, okay, when we encountered this, okay, before actually this, right, let's take this as an example where we actually saw that first example, right? So this is the way. So we'll start from here. Okay, so now, right, so we'll be having our start index to -1, right? We'll be having here, and we are doing the processing from left to right. Okay, and whenever we just started here, we encountered an invalid character, right? Like, I mean, we just encountered a closed parenthesis which does not have anything matched parenthesis in the stack because we didn't push it yet. We didn't push it yet. So in that case, what we'll have to do is, whenever we encounter a closed parenthesis, we need to check if there is something in the stack or not. If there is something in the stack, we'll do the processing, okay, to calculate the length and everything. If we don't find anything in the stack, it means that we encountered a closed parenthesis, but there is no matching thing, right? That's an invalid thing. So what we'll do is we'll start set our new start pointer, right? This was our initial start pointer. We encountered an invalid one, so we'll move our start pointer to this one. Okay, so our start pointer will start from here, and then the actual calculation will continue, right? Like I mean, again we'll start from here, and the next character will appear. Like I mean, we'll be pushing this to the stack. Okay, we'll be pushing this to the stack, and whenever we encounter this, we'll pop it out, and we'll calculate the diff between the start and this one, correct? So that we'll get a length. Okay, now what we'll do is, let's check the code quickly. So what we have done is we have initialized the start to the -1 to get a full length, right? Full length in this condition, right? We'll let's say that if we are in this condition, we'll need some start pointer to calculate a length, correct? So that we have initialized our start pointer as -1 initially. Okay, and then we are iterating, and whenever we enter a open bracket, we are adding it to the stack. Whenever we are getting the closed parenthesis, right, we are checking if there is anything left in the stack or not, right? If there is nothing left in the stack, we'll be updating our new start pointer, right? Which is, and wherever it is invalid, right, we'll point to that. Okay, so now when let's say that there is something in the stack, we'll pop it out. Okay, we'll be popping it out and doing the calculation for the max length. Okay, so there are two things to keep in mind when doing the calculation. Now let's see. Okay, we have this example. Okay, previously what we have saw was, let's say that whenever we're doing the calculation and whenever we encountered a closed parenthesis, right, we will take a full maximum length, right? We'll take a diff from the start. This is our start pointer, right? -1. We'll take a length from there, correct? And so now what's happening here is, let's say that, okay, I will push this to the stack, push to the stack, push to the stack, and whenever we encountered it, we popped it out, and we are taking a diff. So it is 0, 1, 2, right? 2 -1 is like we are getting a length as 3, correct? We are getting a length as 3, and once again, yeah, right, we'll get a 3, right? Similarly, when we go to 3 and 4, right, when we do this calculation also, this is our final closed parenthesis, right? Even though if we do the calculation, 4 minus of -1 will be 5, right? We are getting the answer as a 5 here, but the thing is the valid parenthesis is only 4, correct? We don't have a closed parenthesis here, correct? We don't have a closed parenthesis, but still we are considering this as this into our condition, right? Calculation, correct? So that is the thing. So what we'll have to do is, so what does it mean is, we shouldn't be relying on the start item all the time. Okay, so now we have got a two condition such that we'll rely on the start item only when there is nothing left in the stack. Okay, if there is nothing left in the stack, it means that we can go to our starting pointer, right, to do our calculation. But if there is anything that is left in the stack, right, we'll do our calculation from there. Okay, so what does it mean is, let's say that here, right, we will take the same example. We will take the same example, and when we are doing the calculation, we'll be doing from left to right, right? And when we encounter a close, we'll push this stack, push to the stack, and when we are open with this, and we'll pop it out. Okay, we'll remove this, we'll remove this element. Okay, and we'll check if there is still element left or not. If it is left, we'll do the calculation from there, right? So what was the answer? 0, 1, 2, right? 2 minus 0, our length will be 2. This looks good, correct? This looks good. And next thing is, what we'll do is, we'll push this to the stack, we'll push this to the stack, and when we pop, right, when we pop, this thing is already gone, correct? Thing is already gone. The last element that is present in the stack is 0, correct? And this will be 3, this will be a 4, and whenever we encounter this parenthesis, we'll be popping this also out. So now what we'll do is, 4 minus 0, our length will be 4. This will be the, we'll be comparing it with the previous maximum, and we'll be getting this as a maximum one, 4, correct? And now, right, okay, let's say that now we got a proper length, right? Length is equal to 4, and we are not considering that as the start index. So this looks good, right? We'll have to rely on the previous element when there is something left in the stack. There is something left in the stack, so we'll be relying on the previous element. But in the case of, let's say that we have this, right, will not be having any element to do our calculation, right? So let's say that we'll start from here, push to the stack, push to the stack. When we come here, we'll pop this part out, we'll pop this part out. Okay, we'll pop this part out, and we'll do our calculation, right? Like 0, 1, 2, 2 minus 0, length will be equal to 2. And when we come here, when we will also pop this out, and then when we do the calculation, length will become 4, length will become 4. And when we encounter this, right, we'll be popping this out first, correct? We'll be popping this out first, and we don't have anything left in the stack. We need some pointer, right, like to take a difference and all. In that case, what we'll do is, we'll use our previous start pointer. So what it will be, like 0, 1, 2, 3, 4, 5, right? Our index, this is will be 5, and we have set our start pointer as just previous to this, so it will be -1. So 5 minus of -1 will be equal to 6. So in this case, we have got an answer as a 6, as expected, correct? So to summarize here, right, so what will happening here is, so Let's say that if there is anything left in the stack, we'll use our previous element to do the calculation. If there is nothing left in the stack, then we'll have to go with the start pointer that we had set. Okay, so now to summarize what we had done here is, so initially we have set our start is equal to just before our string, so that we can calculate our length. Okay, and then we started iteration, and whenever we encounter close parenthesis, we added it to the stack. Whenever we encounter close parenthesis, we'll check if there is anything left in the stack or not. If it is if it is not left, it means that it's an invalid or closed parenthesis, so we'll be updating our start pointer. And there, if it exists, right, if there is something in the stack, we'll pop out the last value, and we'll check if there is anything left in the stack or not. If it is there something, right, we'll use the previous element to do the calculation. If there is nothing left, then we'll use our start pointer to do the calculation. That's it. Thank you.